Here.
Hello.
Today we will have a consolidation on chapter 39 before we proceed to the next chapter, and that will be next week. So today we will focus on doing the exercise on chapter 39. Just wait for me. I would like to get the page ready before I start. Can you see this? Okay, this is the page. I asked you guys to do it yesterday. Okay, you are going to find it yesterday. I asked you guys to do the two questions, the following two questions, 23 and 24. I would just give you the numerical answer only this time because I suppose all of you have done it. Okay, or maybe you can give me yours. Anyone who knows the answer for this? Yeah, let me see. Oh, how come? Yeah. Yeah. So strange. Now, 23. Anyone who can help? Tell me. 23. Unit. The volume of the container for 23, it is, some of you will mark it as 10.5. Any other answers? 10.5 dm3. It's 1.24. Yes, that's right. It's 1.24. Wait for me. I don't know why. Why I just want to switch those. The chat box. And why is it still here? Wait for me. I need to. Yes, I was to somewhere. Yes. Okay. The answer is 1.2 dm3. Questions? Anyone who have difficulty, let me know now. For those who you find it quite hard to answer this, all of you know how to solve this. Now, the question is you are going to find out the equilibrium concentration of this equation, right? Of this carbon monoxide, hydrogen gas, as well as methanol. So the question is you are going to calculate the equilibrium concentration of those, and that is the key point. So you have to find it out. So originally we have got 2.0, 4.0 gram or mole of CO and hydrogen respectively. Okay, so what you're going to do is to find out at equilibrium. Well, we have got this, right? So here comes, you should minus something. Well, you should minus something. And this one is just 1.61 is at equilibrium. So you know that the container would have any information about the container. Is what I don't want. I don't know, right? So this is the volume. Now the question is what is that in the boxes? So it depends on your initial concentration, right? So you know the concept about initial concentration, which is originally 2, 4, and this one is 0. Okay, so What is the change of this? This is our concern. We have a change in 1.61 mole, and because of this, we have got this one. It's minus 1.61, and more for this one is 1.61 times 2. This is 3.22, and I use this as a start to do the calculations. While for Kc value, second, you need to be very aware of the Kc value, okay? And over CO gas and hydrogen gas together with this is a square. It's in form of a square. So by doing so, you are going to substitute all those and do the calculations, and here comes B equals 1.24 dm cubed. Questions? Easy, right? A little bit time consuming on shifting the terms to and fro. And the similar questions occur at 24. Very, very similar. Again, you're going to calculate the volume of a container. So this time, I don't want to do the steps for you. It's your turn. 5.53 dm cubed. Any other questions? Any other answers? 24. The answer is 16.6 dm cubed. Okay, so you are going to do the same thing. Very similar. I must have very, very similar. So because this is in 2 mole, and this one is just 1 mole. So for this part is that it helps you calculate the equilibrium concentration. Okay, equilibrium concentration of NOCl. So this 1.60. So you use this data, you may find that we have got a minus 1.60 mole for this part, produce 1.60 mole. While for this part, it will have a minus what? 0.800 mole. This is what you get approach to the problem. Okay, and I do the same thing at question 23, and here comes the answer, 16.6. Questions? Any questions? Now, if not, take a look on question 25. 25, it is a little bit more difficult. 3 thumbs, and you may have CO plus chlorine gas to form COCl2. This is the volume of a sealed container. Volume sealed container. I maintain at 74 degrees Celsius, contain, or initially contain this one. It is also all those that are just initial conditions. And you are going to calculate the reaction quotient. So what you are going to do is to find out QC. Okay, is to find out QC and try to check against the KC. What is the KC? KC is 220. I use this as a matching. You are going to match the two. How? So we will have this one. Okay, you are going to find out reaction quotient. Give you some time on doing the calculations of reaction quotient. So what is that? Reaction quotient, it is the concentration of COCl2 gas at certain point. Okay, at that point, but not equilibrium, and CO, as well as what? Cl2. Okay, and what you're going to do is to get substitute all those data. Okay, we have got 1.50 over 10.0 mole per dm cubed, 1.20 over 10.0 mole per dm cubed. More of the final one is 1.00 over 10.0 mole per dm cubed. So we will get the answer. It is 12.5. Now I would like to focus on the units, right? The original unit, it is mole per dm cubed minus 1. Okay, this is what you may get, right? So you are going to change it a little bit, rearrange those positive terms before it and negative terms at the end. So this is the answer. Questions? B. So you may find, what is that? When you compare it with KC, KC is 220. So you may know QC is smaller than KC. So what is the whole sentence you need to write down? To restore QC to KC, okay? So what you need to do, COCl2, concentration must increase, while concentration of CO gas and chlorine gas should drop. It is brought about by a net until an equilibrium, right? Until equilibrium is attained. This is brought by carrying a net what reaction? A net forward reaction. Net forward reaction. So you turn it to the questions. You are going to refer to questions. Whether the forward reaction or backward reaction rate is greater. Okay. So because of this, you are now going to answer the questions. So the forward rate, okay, is greater than the backward rate. So this is the final sentence you need to write in order to answer the questions. Forward reaction is greater than the backward reaction. Questions? For those who understand what is that, okay, let me know. You understand? Or anyone who still don't understand now, put across. A little bit. How about the others? I just want to check who know it or do not know it. Zhang Gaowei, you know it or don't know it? Marcus or Kiêu Lao, you know it or you don't know it? Ian Cole, Chen Zihin, Zhang Quanwei. But have you checked the answers? Not yet? In progress, right? Just wait. How about the others? Mặc Kiều Lão, where are you? Mặc Kiều Lão. Mặc Kiều Lão. Are you with me here, right? So you know what's that? You know that why you don't know? Have you watched the video? Mặc Kiều Lão, have you watched the video? Chen Zihin. What I mean is the video of equilibrium, but not still me telling it's okay. Chen Zihin, Zhang Quanwei. Siêu trầm hệ. You know what's that? But can you calculate it by yourself? You know it, right? Or finish? Finish? If finish, I would like to cross out this, and I would like to continue on C part. C part. C part. It is okay. Quadratic equation. C part. Right? Your old friend comes again. Calculate the concentration of COCl2 at equilibrium. Okay, constant equilibrium concentration of COCl2. I use this data. So you know that the equilibrium is you are going to have a net forward reaction. Okay, this is what you stop at this part. So what are you going to do is to find out what will happen, right, in the situation, in the real situation. So you know that the initial concentration, and what you need to write down is the equilibrium concentration with the corresponding units, mole per dm cube. Okay, and you are going to let the equilibrium concentration, I don't know what is that, but at the initial stage I know 1.20 over 10.0, 1.00 over 10.00, 10.00, 10.0. And finally here, what is that? It is 1.50 over 10.0. And I know that the equilibrium will be shifted here, right? Will shift it here, right, on towards the right-hand side. So which means that you suppose we have got 1.50, what is that? We've got mole, right, per dm cube. Actually, all those there are just mole per dm cube. Sorry. How come my mark is cube? This should be cube, and mole dm cube. So at that equilibrium, it is for this part, right, net forward reaction, which means I add something to it. Can you get my point? I add something to it. So what is x? X, it is what? The and newly added number of moles of COCl2. Okay, newly formed, not newly added, because I don't want to confuse you. This should be newly formed. Better write down newly formed, right, for the attainment of an equilibrium. Okay, so what's next? So what's next is to get to know this part. Okay, you are going to find out this part. It is mole. This is dm cube. So leaving behind is on this, right? You know that the change is plus x mole, right? So what will happen to this? 1, 1, 1 mole ratio. So you may get, right? So that we've got a net forward reaction, which means there is a consumption of the reactant. So minus x and minus x for the three cases. Okay. So what you need to do is to write down 1.00 minus x over 10.0. Okay, it is mole per dm cube. Now I just skip the unit here. Yes, that's right. 1.20 minus x over 10.0. So what's next is to get to know the KC. Now, the second question, right, is point 1. If you can answer all those correctly, you can score 1 mark. You can score 1 mark. Okay, can you get a point? That is the first mark. I would like to draw attention, 1 mark. How about the second mark? Now, if you can answer the equilibrium constant, you can get the second mark. The expression. Just write down the expression first without doing any substitution of data. Please don't substitute any data. You know, save, keep yourself. What you write it must be correct. What is that? Concentration of COCl2 gas at equilibrium. CO gas at equilibrium. And also Cl2 gas at equilibrium. Right? We have got that three. Understand? So what's next is to write down those terms. I put it downward. 1.50 plus x over 10.0. Okay, this is one thing. 1.20 minus x over 10.0 and 1.00 minus x over 10.0. 10.0. 0.0. Now here comes the value 220. And finally, you are going to get x term. But you may find this is very, very difficult, right? You are going to rearrange the terms by yourself. Right? Do it now. Rearrange the terms by yourself. So what will we get? We will get x squared plus what some of the x plus something equals 0, right? So you may get something like this. Okay, tell me what are those? Do not get confused. So what will you get? Now, I know that some of you will need some time on writing those. Yes, correct. So what are those three terms? The first term is 22. The second is minus 49.4. The third term is 24.9. So I would like to remind you here that it is quite different from what you calculate in mathematics, okay? Because for the x term and the constant terms, they are in decimal place. Don't worry, they are not. They will not give you an integer, but you can still press it in your calculator, okay? But you can still press it in the calculator. So what is the x value of x? I'll give you some time until you can get the correct answer. X, what is that? We've got two data, right? 0.764, okay, or 1.48. Anyone who can get the answers? Put a thumbs up, let me know if you can get these two. And for those who cannot get this, okay, let me know as well. Somebody say that you need to reject 1.48. Why? Again, now please check the data. It's not plus, it is something minus, right? You cannot minus the data which is more than the initial number of moles of the reactant. Can you see that? Now, what I want to tell you is on here, but you cannot. This part and this part, can you see that? Right, the original number of moles of carbon monoxide and chlorine gas, it is just 1.20 and 1.00 mole respectively. So we cannot subtract the data larger than these two. So 1.48, it is too much. Can you get a point? We cannot subtract, right, the larger data than this two, 1.20 and 1.00. Okay, which means that whenever I get the data which is larger than 1.00, the answer must be incorrect. You have to reject. Can you get a point? But not not 1.48. Now, what Lam Ka has been suggested is from the main row as 1.48 as a reference point. But my explanation is on the perspective of what? Of the reactant. Can you see the difference? So the answer is not less than 1.48, but the value of x must not exceed 1.01. Can you get the difference between the two statements? Marcus, can you get my point? You can get the difference, right? You know it. You know it. The reference point is not 1.48. The reference point is from the reactant side. Okay? Especially the smallest number, 1.01. So that's why I just say you that you have got the x term to be calculated. Please reject the data larger than 1.01. Of course, if you have another scenario, right, as very often when solving quadratic equation, you may have one positive term and one negative term. Of course, this time negative term can be rejected. Okay. So what is the reason? If you have got one negative value, so you have to reject it. Why? Now think of the chemistry again. So what is mean by minus something? So you cannot what? What is mean by I will not have minus mode? What's mean by that? So the x term must be a positive value, right? Because originally what you mentioned about CO3, the x term refers to a positive number. Okay, it should be a positive number because it is a newly formed number of moles of Cl2, which means, of course, this one must be a positive number. Otherwise, you cannot explain, you cannot tell it is newly formed. Okay, origin is 0. We don't have such, and we have got this something extra. Extra means positive, right? Can you get the point? So you are going to solve it here, but it's not the end. You are going to refer to questions. Calculate the equilibrium concentration of this. Hey, come on, hey, I just give you another situation already. Can you get my rhythm? Maybe I'm speaking too fast. I know, right? You just tell me from your D's and words that I'm speaking too fast. So the equilibrium concentration of COCl2, it is, remember to leave this one before you end up this question, right? You still need to write down this, continue, right, by putting this. Questions? Any questions? Now I'll give you some time to digest this part. Any questions? No? Really no? Is it okay if I remove all those? Remove all those materials here, right? Do you need to have to capture the screen? No need. All those are there. Hey, you just need not you need not just say okay, but also you have to practice, and you are going to show me in the quiz that you have really watched the video, but not just using your own way to solve the questions will show unclear steps, and I still don't know what you're going to have. I'll just tell you，就係 very clear. I hope this adjective also suits for your work. Now, question 26. Question 26, what is that? Now you refer to the part again. Question 26. Sorry about that. Yes, 26 here. Now this one, very similar, right? 25 and 26 is very similar. It's your turn. This time I don't want to talk too much, right? It's your turn to do something similar to solve chapter 26. Very similar, right? Can you see that? Very similar. Your turn. Your turn. Please, I will give you about 5 minutes to do this work. Okay? And after 5 minutes, I will check your answers here, whether or not this is correct. Now it's your turn. It's your turn for the whole class, right, to do it. First of all, first 5 minutes for A part. Okay, first of all, 5 minutes for A part, A1 and A2. 26. Now let's have somebody to write down those things on these two places. And after 5 minutes, after 4 minutes this time, just let me know if you think that all those they are correct. If this is okay, I would like to check your answers here. For those people who have got some doubts, you have to let me know, right? You can send message to me now. For those who really don't understand what is that. All right, 2 more minutes to go. Hey, it's not just 1 or 2 person who do the work. Can I have more? Now for QC, this part, any unit. What is the unit? What is the unit? Yes, no unit. So this part is correct. Okay, to the cross them out, let others know. Second. It's not tricky at all, Marcus. Please check the overall indices in the numerator and the denominator, and you can know. You have to check. You just somebody who just skip that QC, right? What's that? Oh, you know it, right? Thank you. Please, for the time being, please do not uh, rub it here. Hmm. So, oh, I know, I understand what the problem, right? So for the B part, somebody who still don't know what is that, you need to write down the whole sentences, right? QC is greater than KC. So, yeah, take a look at one journal's work. Restore QC to KC, AI is increase. Yes, that's right, exactly. So maybe you can just directly copy Wang Junshou's work. This time, this part is okay. This one is nice. This one is very, very nice. You see the Wang Jun's work, right? Yep. Okay. You know what's that? Okay. Yeah, correct. Correct. Right, forward race. Yes, that's right. Correct. You get it? We still have B part. Now B part, it is again quadratic equation. It's quadratic equation. Have you capture it? Give you 5 seconds for 5, 4, 3, 2, 1. Captured. Yeah. So question is for B part. Your turn. What's the first step? Write down the equation, right? And showing the initial concentration and the final concentration of the two. So we have got hydrogen gas plus I2 gas to form 2 hydrogen iodide gas. So you are going to find out the initial concentration and the equilibrium concentration respectively. Now show me the data here, right? Show me data. You place, you may see the data, right? 0.20 mole of hydrogen. So what is that? It's original concentration. And Now, first of all, please define it well. What is x, first of all? What is x? Plus or minus, very confusing. Now, for the last questions, you are going to plus something at the product side. Well, for this question, question 26, you are going to plus something in the return side. Do you know why? Under what situation do we need to put a plus or minus on which side? Right? So you need to check what? Yes, that's right. You need to check the QC value against KC value. Which one is, you have to check whether or not QC is larger than or smaller than. And you need to know the concept of net forward or net backward reaction. Can you get my point? So in this case, as said by Wang Zhenhou, right, you know that the final statement is the net backward reaction, which means that initial concentration with that content here, finally, what will happen? They will experience a net backward reaction. So we've got that sign, right? So which means that part of this HI will be consumed some of them, while for these two, what will happen? They will form some. Can you get my point? So that's why form plus, consume minus. You can get the point? You understand? So please check the x term or 2x. What is that? Now 2x, it is referring something which has been consumed, okay? It has consumed 2x moles of HI. So you are going to let 2x mole, right, be the number of moles of hydrogen iodide, okay, to be consumed to attain equilibrium. This is the first part. Yeah, right, correct. This is first part. Second part. Show me the case expression first of all. Okay, remember all those three, they are referring to equilibrium concentration. Correct. Okay, 1 mark. And then, what's next? Continue, right? Of writing those data inside that. Okay. So show me the quadratic equation in the next sentence. What x squared terms, what constant term equals 0. Okay, save time. So 1.80 minus 2x, okay, over what? Over 2.00 square, okay, over 0.200 plus x over 2.00 and 0.240 plus x over 2.00 equals 54.0. Now, do not be so excited to proceed. Try to take a look on that 2x, 2.0 term. All those can be cancelled out. Okay, so you start from these equations to continue. So what will you get to be this x squared term? This is 50 Okay, and then this one x, it is 30.96, and the constant term it is minus. This is minus what? 0.648. What will you get for that x term? 0.0203 or minus 0.93639. You know, the negative data should be rejected because you are going to consume something, right? Which must be positive, right? It's not negative data. So you keep this data. But you are going to find out the equilibrium concentration of HI. Now you can write down abbreviation, right? Just this one already tell it is equilibrium concentration of HI. So what is that? HI, you use this data. You use this formula and solve it again. Can you see that? You use this one. So which is equal to what? 1.80 minus 2x, right? Get substitute back the x, and you can get the answers. Yes, that's right. It is 0.880 mole per dm cube. Questions? Questions? Do you feel nice? How many of you would think that you can tackle? Right? For those who think you can tackle, please clap your hands. Let me know you can handle this. For those who still cannot handle, thumbs down. Two. How about question 27? Now, question 27, can you do it by yourself before we come at 9? Can you do it? Question 27? It's easy. It's easy. No quadratic equation. Don't worry. Don't worry too much. If you can finish 27, I do hope we can we have a, now I try to see if most of you can manage. If you think most of you can manage 39, maybe I start chapter 40, or you want to do more exercise. It depends on your level of understanding for those questions at 9. Question 27. Can you do it by yourself first? Because all those, they are just stepwise procedure, right? Whether or not you can do the exercise depends on the classmates' extent of understanding. For those students who may have difficulty, we have to continue on doing the exercise. So that's why I ask you guys to go home and do it, those, especially for those quadratic equation by yourself, and try to see if you can manage. Let me put it this way, okay? First of all, I give you some time, all of you, please refer to those remaining questions, okay? and try to see if you can manage. If you fail to manage, okay, it depends on your the popularity of the others, right? For the major students, for those who still need to continue, we will continue. Otherwise, we will stop a little bit on chapter 40. Any more questions? Okay, the time now is 2:11. Okay, I will stop it here. Work hard for your red dots quiz. Bye bye.